Okay, so I am going to speak to how to design figures for accessibility, which is a big topic. And I'm not going to be, I'm going to start at the beginning, which I think is the only place to start. So let's go to the next slide. So the first thing that I want to talk about as far as accessibility is concerned is legibility, which is, can the people who are looking at your figure read it? Um, a big culprit with this is that people use font sizes that are too small. And so the example on the screen is too small. You're probably squinting at it being like, why is it so little? The recommended point size that's the minimum. I know in our publication manual it says 6, but that's itty bitty. And I think 9 is a better target to try to get to for font size. But the bigger is usually better in terms of getting people to be able to actually understand your meaning. Similarly, for figures that are going to be viewed at a distance, such as in presentations and posters and on slide decks, use larger fonts. There's not like one answer for what the size should be, but the farther away the audience is going to be, the larger you want it to be. And then a last consideration with legibility is that you want to make sure that the figures that are getting reproduced from another source are sufficient quality and not fuzzy. Particularly if you're resizing a figure or like it was published and it was really little in its original interpretation, you need to be able to, it needs to be have good line quality on it. So paying attention to those is going to help increase the legibility of your figures. Next slide, please. So a second consideration with figures is the use of color. Color is an appetizing way to make figures more engaging for readers, but it also comes with some dangers to be aware of. You certainly want to prioritize high contrast color pairings. Good examples would be blue and orange or black and white. One to avoid is red-green, which is shown here, because the most common form of color blindness is red-green color blindness. So if anybody watching today has difficulty telling red and green apart, this figure might be very challenging to understand. So Jasmine, if you click on the screen, we will see a better alternative here. This better alternative is this blue plus orange pairing. A great way to check for color contrast is to ask, could I understand this if it was printed in black and white? If you have access to a printer, you can even print it in black and white and look at it and say, do I still understand it? And then another way to check for adequate contrast is to use color contrast checkers, such as one that's made by WebAIM. And that's their logo on the screen. I think it's webaim.org. So it's not like there's one set of color pairings that's good or that's bad. There's thousands of colors that are possible in the world. And there's also considerations depending on the number of colors that you're going to use. But if you have like a 2-color pairing, the ones shown here, like blue and orange, is a great place to start. Next slide, please. So continuing talking about color, as you start to include more colors, it can get more difficult to choose a set that you can distinguish all the colors from each other, especially considering issues like color blindness. And so a great strategy is to label the elements of the figure so that the meaning doesn't only rely on the color. And so in this example on the screen, the key at the bottom is disconnected from the line. So you need to be able to distinguish these 4 colors, which are not particularly easy to distinguish, in order to tell which is what. And so if you click, and we'll get to the next example. And so here I've labeled the lines by put it instead of having the key. So now it doesn't really matter what the colors are because the lines themselves are directly labeled. And so this is a great way to reduce like the cognitive load of people trying to figure out matching the colors. If you click again, I'll show you another example, which is that you can use different line styles to differentiate the data. And so here we've got solid line, dotted line, dashed, dot dash. And I'm even here using this in combination with the extra labels. And so you can use a combination of strategies to make sure that readers can know what information belongs to what group without only relying on color. Let's go to the next slide. Thank you. So I saw in the chat that a lot of you are asking about what software should I use to design my figures? And I love that question because our number one advice is that you should use software to design your figures. There's figure building software incorporated into common word processing programs like Microsoft Word and in Google Docs or Google Sheets. You can create figures through Excel. You could use statistical software like SPSS, R. I've heard positive things about Prism being a tool that people use. Um, Students sometimes might use something like Canva to just to design figures. But the point is that using in your word processing program the add chart function and then using that to make your chart is going to be better than trying to like draw the shapes and sort of assemble it yourself. So that's my number one suggestion, is to make sure that you're using some kind of software. Then once you're doing that, you're going to need to go through and check for the appropriate labels in the figure. For example, earlier in the presentation, Jasmine was talking about axes in graphs needing to have labels. Sometimes when you generate the figure in Word, it doesn't automatically come with the axis label, and you need to go add chart element and put the axis label in. Likewise, if you are designing a figure for an online presentation, you can add something called alt text to the figure, which is what somebody who is blind or has low vision would read instead of looking at the figure. And so that is like a whole other bigger subject that we don't have time to get into too much detail today, but using software, there's going to be a place where you can add the alt text to the figure. They've thought of that already, right? Similarly, within your software, you're going to want to check for the color contrast. You're going to want to check for the adequate point size for the font. And a last consideration for using software to design figures is that I've heard about people using AI to design figures, and I would be careful. I tried asking ChatGPT to make me the same figure that was on the previous slide, and this was their accessible version of the figure. And as you can see, like it's grainy. You can't edit it yourself. There's all of these extra lines going on. The title isn't what I wanted it to be. And so if you're a power user of a particular AI program and can get it to reliably make the figure that you want it to, that's great. However, I do think there's a lot of value in understanding how to build the figures yourself within whatever program that you have access to. And within that, I think that a good place to start is by understanding what kind of figure that you want to make. So for example, if you're in Word and you want to build a figure, you might say, okay, I'm making a line graph, and you select line graph. And then you think about what are the qualities I need a line graph to have. I need the axes to be labeled. I need the different data series to be distinguished by more than just color, and so on from there. And another great tip is to look at effective figures in works that have been published that you've seen in your research, and to sort of emulate well done figures that you've seen out in the world. All right, thank you. And then I think we're ready for the next time of questions.